when that buckling failure will be there, before that before load is applying on that column, the length will be total length, but after buckling then there will be effective length. So there are different conditions like this. So here slenderness ratio. What is here slenderness ratio means? Slenderness ratio of a compression member. So column is always a compression member. There is a short column will be there and long columns will be there. So slenderness ratio of a compression member is defined as the ratio of its effective length to least radius of gyration. So here the formula of that slenderness ratio is lambda is equal to effective length by least radius of gyration here. So in problem we'll see this problem, how can we solve with this. So here this is the slenderness ratio. So this is the first problem. First I will see here problem on calculation of slenderness ratio for column. So our question is a steel bar of rectangular section 40 mm into 50 mm. So see here how it will be 40 mm and wait. I will write here given data so you can understand. This is the cross section of the column. So here, what is our given data here? A steel bar of rectangular section 40 mm into 50 mm pinned at each end. So pinned at each end means here the effective length formulas will be there for different conditions. So here pinned at each end is subjected to axial compression. So rectangular section 40 mm into 50 mm. You can see here. This is the breadth is 40 mm and depth is 50 mm here. So here like this x and y by axis here. So you can see here x and y. As per our condition, we have to calculate minimum. So if we are calculating x section and y section, so here a steel bar of rectangular section 40 mm into 50 mm, 40 mm into 50 mm. So here the area is the area is 40 mm into 50 mm. In a given data, area is 40 mm into 50 mm here, area. And what is the cross section here? This is the rectangular cross section. Rectangular cross section. And the bar is 2 meter long. The bar is 2 meter long. So determine the buckling load and the corresponding axial stress using Euler's formula. Euler's formula means that 4 conditions. So already they gave here pinned at each end. Also calculate slenderness ratio if the proportional limit of the material is 200 Newton per mm square here. So here see, you can see here given data, rectangular section, area is 40 mm to 50 mm, and here they gave here the proportionality limit here, the material is sigma c means stress is 200 Newton per mm square. See here, stress is 200 Newton per mm square will be there. 200 Newton per mm square. Next, here they gave Young's modulus here, means elasticity of that material. How much they gave in problem? X modulus is 2 into 10. This is the basic value for our mile steel also. 2 into 10 to the power 5 Newton per mm square here. 2 into 10 to the power 5 Newton per mm square. So it's the 10 to the power 5. This is the mm square. Mm square. So here we have to calculate. These are the given data for us. Rectangular section and length is 2 meter. So here we have to calculate here stress and at the corresponding of the axial, what is the load is compression subjected to axial compression. And see here our column is like both end of the column are pinned or hinged. So what is the effective length here? The effective length will be same. For this condition, pinned at each end. So pinned at each end means L is equal to L only total. There is effective length means if both side is pinned, so the effective length will be same. So there is no L by 2. If L by 2, L under root by 2, there is a different condition. So the 2 meter, the bar is 2 meter long. So effective length will be 2 meter only. Why? Because here pinned at each end. Whenever the force is applying, here the pin will be there. The up to that pin only, that effective length we have to total, means the bending of that member is exactly at from total length means effective length in this case. So next here, now Euler's crippling buckling load is given by, so this is the formula for us here. This is the formula. Pi square E I minimum by L E square means effective length here. So I minimum means here, this is the XX section here. Here XX section will be there. In XX section, they gave already here the cross section of the column. Which one is the XX is and Y by. We have to calculate here moment of inertia. So moment of inertia for given rectangular section about x-axis is given by IXS. So this is the formula for us, BD cube by 12. When it will come to y-axis, then it will be dB cube by 12. So first we'll see BD cube by 12 here. So in given data, if IXX equal to BD cube by 12, BD cube by 12, T is equal to, for us, what is the breadth here? Breadth is 40. 40 into depth is 50 here. Depth is 50. So cube here. BD cube by wait, BD cube by 12. Then the value will become 416.67 into 10 cube mm power 4 here, mm power 4. Mm power 4. So same we have to calculate moment of inertia here. Moment of inertia for a given rectangular section about y-axis. So about y-axis here, Iyy equal to db cube by 12. Our formula, you can see here our formula, db cube by 12. So here db cube by 12 means here our depth is 50 and breadth is 40. So directly I am writing here 50 into 40 cube by 12. 40 cube by 12. So here answer will become 266.67 into 10 to the power 10 cube mm power 4. Same. So here, which is the least one? Can you tell me? Now answer, which is the least one here, Ixs or Iyy? Reply. Which is the least one here?
Iyy, sir.
Iyy. So మనకి ఏంటి here condition will become the, see here, Ixs is greater, no, here Ixs is greater in our condition. Ixs is greater, so hence I minimum, we have to take I minimum value 266.67. so here already in formula pi square, what is pi value? Pi value 3.14. Okay, so here already this formula, see, P equal to pi square E I minimum by L effective, means effective length. So here pi means E value, we already in problem E value they give 2 into 10 to the power 5. So here I minimum we got here least value 266.67 into 10 cube. So and here effective length, what is effective length here? They already in problem they give 2000 means 2 meter. So after calculating this, we'll get here this value as 131.60 10 cube Newton or 131.60 kilonewton. I am writing here answer. We got here PE value as 131.60 kilonewton. So next here in problem, what they told for us, determine the buckling load and the corresponding axial stress by using Euler's formula. What is the next condition here? Also calculate. Can you see here slenderness ratio? Also calculate slenderness ratio. Okay, for slenderness ratio, now say axial stress induced in the column because of Euler's crippling load. So the Euler's crippling load will be sigma equal to P by A, as stress equal to force by area. No, we know already here stress is equal to force by area. Stress is equal to force by area here. Stress equal to force by area. So what we got here, value 131 point. In Newton we are taking here 131.60. 131.60 into 10 cube. We got stress here. This one. Stress. So if we calculate this divided by what is the area for us? Right. What is the area for us? Area. Reply. 40 into
50.
40 into 50. This is the area. So directly here I am writing here 40 into 50. Okay. Here 10 cube. Can you calculate this and tell me answer? What is the answer?
65.8, sir.
65 point. You will get some 65.79. Okay. Approximately 65.79 Newton per mm square. Newton per mm square. Okay. So next, Euler's load is given by this formula. I will write here. Euler's load will be given by PE equal to P equal to, so here formula, what is the formula here? I square E I minimum by L effective means effective length. So here I minimum means what? I minimum in slenderness ratio. I will write here pi square means I am directly writing 3.14. 3.14. into E I minimum. E means what? E value for us. This is the E means. Now just see here. How can we convert this formula into slenderness ratio? Here pi square E I minimum by L effective. So can we write here I minimum is equal to AK square? Can we write here I minimum is equal to AK square? Because here see in bottom K is equal to radius of gyration. So K is equal to under root I by A. Under root I by A. From this we can write here I is equal to K square A. So as we are calculating for minimum, previously we got no Ix and I by Y, we are calculating for minimum. So I minimum is equal to AK square minimum. So that's why we are writing here in the place of I minimum, we are writing AK square here. So from this formula, now what is PE? Upside చెప్పండి నాకు ఇక్కడ Euler's crippling load sigma is equal to what is here? Here. What is this? P by crippling load దగ్గర ఎంత ఉందమ్మా? Sigma equal to force by area కదా? Force by area. Sigma equal to P by A. So directly we can P ఎంత రాయొచ్చు మనం? See here. Stress means stress equal to force by area. So here we can write here P is equal to stress into area. Can we write like this? Can we write like this? Stress into area?
Yes, sir.
Okay. ఇప్పుడు P is equal to stress into area ఉంది కదా? So see here, can we write arrow mark కనిపిస్తుంది? Arrow mark here. So P is equal to sigma C means here crippling load ki. Sigma C into A. and as usual our formula here pi square E I minimum, pi square E I minimum by L effective. Now see here L effective దగ్గర మనము LE by K రాయొచ్చా? I minimum in the place of I minimum we are writing here AK square. So can we write here K bottom side? Can we write this formula like this? Okay, pi square E I minimum in the place of I minimum as we got here AK square. Okay, if I submit here AK square here, so in the place of area, in the place of I minimum, A is top side and we can bring this K as a bottom side. Why we are bringing this K as a bottom side? Because LE by K means here we are getting slenderness ratio directly. Okay, so in the next year can we cancel this A and A? ఇక్కడ మనకి ఈ సైడ్ ఏరియా ఉంది, దిస్ సైడ్ ఆల్సో ఏరియా ఉంది కదా, కెన్ వి క్యాన్సిల్ దిస్ ఏరియాస్? Okay, so our formula will become pi square E by lambda square. Why? Because lambda is equal to slenderness ratio here. Lambda is equal to slenderness ratio. From this we are calculating our slenderness ratio as by putting this formula pi square E by sigma c. So lambda is equal to under root pi square E by sigma c. So here under root pi square into what is E value for us? Already they gave us 2 into 10 to the power 5, and here crippling load also means in the problem they gave 200 here. In the problem they gave here 200 Newton per mm square. If the also calculate slenderness ratio, if the proportional limit of the material is 200 Newton per mm square. Okay, so we calculated first our Euler crippling load. First we took, I will explain again. First, this is a given data rectangular section. There is an area. Okay, what is that? 2 meter long. 2 meter long is there. So we have to calculate here our first our load. What is the load condition? Then stress and then slenderness ratio here. So if the both ends of the column are pinned or hinged, then effective length will be same length. Whatever the effective length will be same length, because here you can see here if both end are hinged, then effective length will become capital L, means total. In the if suppose one end is fixed and other end is free, will become then 2L. If 2L undi, original length ento manaki 2 meter. So what is the effective length? It will be 2 into L. It will become 4 meter. If both ends are fixed, then L by 2. 2 by 2 is only 1 meter. Means 1 meter daake manaki enti bend avutundi. Okay. So these are the different conditions. So here next year Euler's crippling means buckling load is given by, this is the formula. In this we are calculating I minimum value. So moment of inertia for a rectangular section about x-axis is given by, this is the Ix equal to BD cube by 12. So as we know our formula, breadth is 40 and depth is 50 cube. So this is the Ix value 416.67 into 10 cube mm power 4. Next, same moment of inertia for given rectangular section about y-axis is given by Iyy equal to dB cube by 12. So here we are taking breadth cube here. So we got here 266.67 into 10 cube mm power 4. So here as Ix is greater here in compared to Iyy, so we are taking here I minimum value. So I minimum is equal to Iyy equal to, we are taking that value and we are putting all those values in equation 1. So in equation 1 here pi square, as we know common value pi square 22 by 7 or 3.14 into E means in problem they gave E value modulus of elasticity or Young's modulus 2 into 10 to the power 5 into I minimum we got 266.67 into 10 cube, and effective length will become 2000, means L is square. So we got here 131.60 kilonewton. Next, axial stress induced in the column because of Euler's crippling load. So axial stress, what is the axial stress that in the column? As in what is the condition here? If any column is that is failing, suppose the column is failing up to 75 kilonewton, then we have to design for proportionality limit up to 75 kilonewton. We have to not only design, but that factor of safety means some extra up to 100 kilonewton or 120 up to 110 kilonewton we can design it. So For a limit, if column is filling for 75 kilonewton, we cannot design for particular 70 that column for the load for 75 kilonewton only. We have to design that column some extra. It can resist that force, extra force. So here Euler's load is given by we same that formula, but what is the slenderness ratio? From I minimum we are getting here radius of gyration. So directly we can put here I minimum is equal to AK square minimum. So AK square minimum is equal to, in the place of I am writing here I minimum is equal to AK square. So by after getting K square bottom side, so LE by K square means slenderness ratio. From this we can get slenderness ratio as the stress is given here 200 kilonewton. Okay. So see here next problem here. Rejoin again. If meeting will end, rejoin again. Okay. See next one. Problem on calculation of buckling load by using both Euler's and Rankin's formula. Now see what is the Rankin's formula here. This is the Rankin's crippling load. So Rankin's formula is PR equal to sigma CA by 1 plus A. Here LE by K means same our lambda square. So here the A will be given directly in the given data. They will give A value. You can see here now this is the both end of the column is fixed. Both end of the column is fixed means L by 2. Suppose in the given length the column is 6 meter, then we have to the effective length will be L by 2. So what is here? The 3 meter will become, the bending will become at only 3 meter. Okay. So a hollow CI here. CI means the full form of CI here, cast iron column here. A hollow cast iron column has 200 into 150 mm outside dimension. You can see here figure outside dimension. I will draw here. Again rejoin again. I will draw. I will tell. Just I will read here question. A hollow CI column has 200 into 150 mm outside dimensions and 150 into 10 mm inside dimensions. You can see here outside dimension and inside dimension. Capital B is equal to 200 mm and capital D is 150 mm. This is the outside dimension. And what are the inside dimension here? Small b, that is 150 mm and small d is 100 mm here. Height of the column is 6 meter. As we know, height of the column is 6 meter. If both ends are fixed, then we have to divide it with L by 2. So 3 meter will be there, effective length. The column is fixed at both ends. If E is equal to 1200 Newton per mm square, find buckling load by Euler's formula. Also find crippling load by Rankin's formula. So if stress is equal to 500 Newton per mm square and A is equal to 1 by 1600, this will become constant value. Okay. So here given data, a hollow cast iron column, I will write again here. A hollow cast iron column outside dimension 200 mm into 150 mm. Next second, inside dimension 150 mm into 100 mm. Okay, I will draw here that section. So this is the cross section of the column. Okay, so outside dimension is 200 into 150 here, and inside dimension is 150 mm into and total length means, suppose I will draw here again. Total length, okay, total length is 6 meter. Total length is 6 meter here. So fixed at both ends. So here sigma is equal to 500 Newton per mm square and Rankin constant they already give. So what is the first condition for us? For both ends of the column is fixed. So what is the effective length here? What is the effective length? So if the both ends of the column are fixed, both ends of the column is fixed. Okay. So L by 2. So what is the length for us? Length is 6000 mm. So by 2, it will become now 3000 mm, means 3 meter. 3 meter. Now see what is